Welcome to today's training session on RAID. RAID is a fundamental technology in data storage that combines multiple disk drives to improve performance, reliability, or both. RAID was first developed in 1987 by researchers at the University of California, Berkeley, as a way to use smaller, less expensive drives to replace larger, more expensive ones. Today, it's a critical component in many storage systems, from personal computers to enterprise data centers. In this training, we'll explore what RAID is, how it works, the different RAID levels available, and how to choose the right one for your specific needs. By the end of this session, you'll have a solid understanding of RAID technology and be able to make informed decisions about implementing it in your environment. RAID operates on three main techniques: striping, mirroring, and parity. Striping involves dividing data into blocks and distributing those blocks across multiple drives. This allows multiple drives to work simultaneously when reading or writing data, which can significantly improve performance. Think of it like having multiple checkout lanes open at a store. Customers can be processed much faster than with just one lane. Mirroring creates an exact copy of data on two or more drives. If one drive fails, the data remains accessible from the mirror drive. This is similar to making a backup copy of an important document. If the original is lost or damaged, you still have the backup. Parity is a mathematical technique that calculates additional information based on the data being stored. This parity information can be used to reconstruct lost data if a drive fails. It's like having a formula that can recreate missing information if you know the other values. RAID can be implemented in three ways. Hardware RAID uses a physical controller card that manages the array. Software RAID uses the operating system to manage the array. And firmware RAID is built into the computer's motherboard and uses system resources. Regardless of the implementation method, the operating system sees the RAID array as a single logical drive, simplifying storage management. When evaluating RAID systems, there are four key criteria to consider: reliability, availability, performance, and capacity. Reliability refers to the system's ability to tolerate disk failures without losing data. Different RAID levels offer varying degrees of fault tolerance. Some can survive multiple drive failures, while others cannot survive any. This is crucial for protecting critical data. Availability measures how often the system is operational and accessible. If a drive fails, does the system remain online, or does it go down until the drive is replaced? High availability is essential for systems that need to be accessible 24/7. Performance evaluates how efficiently the system handles data processing tasks. This includes both read and write speeds, as well as response times. Some RAID levels excel at read operations, while others are better for write-intensive workloads. Capacity refers to the amount of usable storage available after accounting for redundancy mechanisms. Higher redundancy typically means less usable storage space. It's important to balance storage efficiency with data protection needs. Understanding these criteria helps you select the appropriate RAID level for your specific requirements, whether you prioritize data protection, performance, storage efficiency, or a combination of these factors. RAID 0, also known as striping, is the simplest RAID level. It requires at least two drives and works by splitting data into blocks that are written alternately to each drive in the array. For example, with two drives, the first block goes to drive 1, the second to drive 2, the third to drive 1, and so on. This allows both drives to work simultaneously when reading or writing data, which can significantly improve performance, especially for large files. The advantages of RAID 0 include excellent performance for both read and write operations, 100% storage efficiency, no space is wasted on redundancy, simple to implement and understand. However, RAID 0 has a significant disadvantage. It provides no redundancy or fault tolerance. If any single drive fails, all data in the array is lost. This makes RAID 0 unsuitable for critical systems where data loss is unacceptable. RAID 0 is ideal for non-critical applications where performance is the primary concern, such as video editing workstations, gaming systems, or temporary file storage. It's also useful for read-only data that's backed up elsewhere. RAID 1, or mirroring, creates an exact copy of data on two or more drives. Every write operation is performed on all drives in the array, ensuring that each drive contains identical data. When reading data, the system can access it from any drive in the array, which can improve read performance. If one drive fails, the system continues to operate using the remaining drives, and no data is lost. The advantages of RAID 1 include excellent data redundancy, can survive the failure of one or more drives, depending on the number of drives. Good read performance, as data can be read from any drive. Simple to implement and understand. Fast recovery, just copy data to a replacement drive. The disadvantages of RAID 1 are only 50% storage efficiency, or less with more than two drives, since all data is duplicated. Slower write performance, as data must be written to multiple drives. Higher cost per unit of storage. RAID 1 is ideal for critical systems where data availability is more important than storage efficiency, such as servers hosting essential applications, financial systems, or storage of important business data. RAID 5 combines striping with parity and requires at least 3 drives. Data is striped across all drives in the array, and parity information is distributed across all drives as well. The parity information is calculated using the data blocks in each stripe. If a drive fails, the system can use the remaining data blocks and the parity information to reconstruct the lost data. By distributing the parity across all drives, RAID 5 avoids the performance bottleneck that would occur if parity were stored on a dedicated drive. The advantages of RAID 5 include good performance, especially for read operations. Efficient storage use, only the equivalent of one drive's capacity is used for parity. Can survive a single drive failure without data loss. Cost-effective for the protection it provides. The disadvantages of RAID 5 are slower write performance due to parity calculations. Rebuilding a failed drive can take a long time, especially with large drives. If a second drive fails during the rebuild process, all data is lost. RAID 5 is a popular choice for file servers, application servers, and general-purpose storage systems that need a balance of performance, data protection, and cost efficiency. It's particularly well-suited for read-intensive workloads. RAID 6 is similar to RAID 5, but provides an additional level of protection by using dual parity. It requires at least 4 drives and can survive the failure of any 2 drives in the array. In RAID 6, 2 independent parity schemes are used for each set of data blocks. This means that even if 2 drives fail simultaneously, the system can still reconstruct the lost data using the remaining drives and the dual parity information. The advantages of RAID 6 include excellent fault tolerance, can survive 2 drive failures, good read performance, similar to RAID 5, suitable for large arrays with high-capacity drives, provides additional protection during the rebuild process. The disadvantages of RAID 6 are slower write performance than RAID 5 due to dual parity calculations, reduced storage efficiency, the equivalent of 2 drives capacity is used for parity, more complex to implement and manage, longer rebuild times compared to RAID 5. RAID 6 is ideal for critical systems with large drives where the risk of multiple drive failures is a concern. It's particularly suitable for large-scale storage systems, data archives, and any application where data loss would be catastrophic and rebuild times are long. RAID 10, also known as RAID 1+0, combines the mirroring of RAID 1 with the striping of RAID 0. It requires at least 4 drives and is implemented by first creating mirrored pairs of drives, then striping data across these pairs. This configuration provides both the performance benefits of striping and the redundancy of mirroring. When data is written, it is striped across the mirror pairs, and each mirror pair maintains an identical copy. When data is read, the system can benefit from both striping and the ability to read from either drive in a mirror pair. The advantages of RAID 10 include excellent performance for both read and write operations, High fault tolerance can survive multiple drive failures as long as they occur in different mirror pairs. Fast rebuild times: if a drive fails, data is simply copied from its mirror to a replacement drive. No parity calculation overhead. The disadvantages of RAID 10 are only 50% storage efficiency, same as RAID 1, higher cost per unit of storage. It requires at least 4 drives to implement. RAID 10 is ideal for high-performance, mission-critical applications that require both speed and reliability. It's commonly used for database servers, virtualization platforms, and any system where both performance and data availability are critical. Let's compare the RAID levels we've discussed to help you choose the right one for your needs. RAID 0 offers the highest performance in storage efficiency but provides no fault tolerance. It's suitable for non-critical data where speed is the primary concern. RAID 1 provides excellent redundancy and good read performance, but at the cost of storage efficiency. It's ideal for critical data where availability is essential. RAID 5 offers a good balance of performance, redundancy, and storage efficiency with the ability to survive a single drive failure. It's a popular choice for general-purpose servers and storage systems. RAID 6 provides even greater fault tolerance than RAID 5, with the ability to survive 2 drive failures, but at the cost of some performance and storage efficiency. It's suitable for critical systems with large drives where the risk of multiple failures is higher. RAID 10 combines the performance of RAID 0 with the redundancy of RAID 1, offering excellent performance and fault tolerance, but at a premium price and with reduced storage efficiency. It's ideal for mission-critical applications that demand both speed and reliability. When choosing a RAID level, consider your specific requirements for performance, data protection, storage efficiency, and cost. There's no one-size-fits-all solution. The right choice depends on your unique needs and priorities. In conclusion, RAID is a powerful technology that can significantly improve the performance, reliability, or both of your storage systems by combining multiple disk drives. Key takeaways from this training include: RAID uses striping, mirroring, and parity to improve performance and/or reliability. Different RAID levels offer different balances of performance, redundancy, and storage efficiency. There's no single best RAID level. The right choice depends on your specific needs. RAID provides fault tolerance but is not a substitute for regular backups. Best practices for implementing RAID include: choose the RAID level that best matches your requirements, use identical drives in your RAID array for optimal performance, monitor your array's health regularly and replace failed drives promptly, maintain a comprehensive backup strategy in addition to RAID. RAID can seem complex at first, but understanding the basic principles and the characteristics of each RAID level will help you make informed decisions about your storage infrastructure. The right RAID implementation can provide significant benefits in terms of performance, data protection, or both, depending on your needs. Thank you for joining our RAID training session. I hope you're coming away with a solid understanding of RAID technology and how you can use it in your own environment. If you found this session helpful, don't forget to like and subscribe to our channel. And if you know someone who'd benefit from learning about RAID, feel free to share this video with them. If there's a specific topic you'd like us to cover in future sessions, just leave a comment below and let us know. We'd love to hear your suggestions.